Hi, in this video we are going to talk about set in C++ STL. Set in C++ are used to store sorted data. Say you have some data coming and you want to store it in a sorted way. So what do? You put it in a set. Now after putting it into a set, whenever you traverse this data, you will always get this data in sorted way. Let's understand this with an example. We use insert function to insert an item into a set, and this is how we create a set. We create an object of set class, then we insert items one by one. Now we are traversing the set like any other container. When we traverse the items, we always get output in sorted order. So the output of this will be 5, 10 and 20. The default sorted order is always increasing order, whether it is sorting or set or any other thing. If we want to store the data in decreasing order, then we can use this greater function. This greater function is always used in STL to reverse the order. So what do we get? We get the output as 20, 10 and 5. Now we get items in decreasing order. In this program, I have written a different style of traversing a set. Like other containers, we can traverse a set using begin and end. What happens in a set is, say your set contains these elements. Since we have the greater function used, the elements will be stored in decreasing order. So your set will be 10, 25. Your begin will point to the first element, and your end will point to an element beyond the last element, like vectors, right? So we run a loop, we start from the begin, we get the address of the first element, right? I've used auto here, otherwise we'll have to type that set int then colon iterator. We can also use this in place of auto, but to avoid that typing, we can use auto here. So it begins with 20, prints value at this address, then we move to the next element until we hit the end. So end is beyond 5, right? If you remove greater, then they will be in increasing order, right? So begin always points to the minimum element if you have not used greater, and end will point to the element after the last element. And if you have used greater, then begin will point to the largest element and end will point to the element beyond the smallest element. Here is one more way to traverse the set. Here I have used RBegin and REnd. So these RBegin and REnd, they return reverse iterators. So your set is internally stored like this because we have used greater, so it will be in decreasing order, 10, 5. RBegin, reverse begin will point to this element. And REnd will point to an element beyond the first element. Since this is a reverse iterator, if you do IT++, it will move in reverse direction. So the output of this program will be 5, 10 and 20. Let us now talk about what happens when you insert duplicate values in a set. Say this set is created, now we insert 10, 5, 20, then we insert 10 again. Then we insert 5. What will happen? So set ignores duplicate values. If you try to insert a value which is already there, it is going to simply ignore those values. So the output of this program is going to be 20, 10, 5. These 10 and 5 are ignored. We are getting a decreasing order because we have used greater function here. Let us now talk about find function in set. Find function is used to search an element if it is present in the set or not present. Here I have used find function to search 10 in this set. So this set contains the elements 5, 10, 15, 5, 10, 20. When I call find, it returns iterator to the element if it is present in the set. So it will return iterator to this element, address of this element. Now suppose I search for something which is not present, for example 2. If I pass 2 here, then it will return iterator to the end to indicate that the element is not present. Please remember, end is a special iterator which points to an element beyond the last element. So the output of this program is going to be found, and we can verify that whether it points to the iterator points to this element or not by modifying this program. We can write something like this: while iterator is not equal to s.end cout star iterator. Now this program will print everything after this iterator, including this iterator. So this program will print found, then it will print 10, and then it will print 20. After printing 20, your iterator will move to s.end, and then it will stop because it reaches the s.end. So if your element is present, then it returns an iterator pointing to that element. If not present, then it returns end. Let's modify this program. Let's say if we pass something like 3 to it, an element which is not present in the set. What happens now? s.find will return s.end. So you will get output not found. It will not go into the else part. Then this loop will also not run because iterator is anyways s.end. So it will stop the first check itself. So the output now will be not found. Let us now talk about clear function. As other containers, if you call clear on a set, it will simply remove all the elements. In this program, we have a set where we have 3 elements. Once we call clear, it will remove all these 3 elements from the set. And after that, if we call s.size, we will get 0. So output of this program is going to be 0. Let us now talk about our next function, which is count. Count function, as the name suggests, returns count of occurrences of an element in the container. But set does not contain duplicates. So count function here returns 1 or 0. It can be used in place of find function. Find and count, they both can be used to check if an element is present or not. The difference is find function returns iterator to the element if it is present. Count function on the other hand only tells you whether it is present or not present. Let us now talk about erase function. Erase function is used to remove an element from the set or a group of elements from the set. Here we have created a set with these 4 elements 10, 5, 27. So it creates a set like 5, 7, 10 and 20 sorted order. When we call erase, this 5 is removed from the set, right? So the output of this program is going to be 7, 10 and 20. We can also use erase to remove an element whose iterator is given. For example, we first find the iterator to the element we want to remove, and then we pass the iterator so that this element is removed. This is same as previously calling erase only for 7. So what happens? The output of this program now is again 5, 10 and 20 because 7 has been removed by these 2 lines. We first found an iterator using the find function and then we called erase. We can also use erase to remove a range of elements. For example, I want to remove everything after 7. So if I pass iterator and s.end, it will remove everything which begins from iterator, including iterator, and ends before it. Please remember, end is a special marker. It points to after the last. So it will remove everything before it. If you pass end -1, then it will not remove last element. If you pass end, then it will remove the last element because end is beyond the last element. So what will happen? In the modified program, the output is going to be, what we did? We created a set with the elements 5, 7, 10, 20. Then we found an iterator for the 7, which is here. Now we removed everything from here to here. So the output is going to be only 5 because everything from 7 to end has been removed. So the output of this program is 5. Let us now talk about lower bound function on set. This lower bound function is similar to the lower bound that we called for vectors or arrays. The difference here is this is a member of the set. There we were using lower bound and we were passing vectors as parameters or arrays as parameter. Here it's a member of the set class. So if you have a set class, it's better to use the member function, because then you will not have to pass parameters. You can call that lower bound also on a set, because set allows you to iterate that way. But if you want to call lower bound on a set, why not to use the member function to avoid passing parameters? Okay, let's see how does this lower bound function work. This lower bound function gives you the iterator to the element if it is present. If it is not present, then it returns the iterator to the element which is just greater than this. Now the third case, what if the element that we are searching is greater than the greatest element? Then this lower bound function returns s.end. Let's see what with an example. Here we have created a set with elements 5, 10, 20. And we are calling lower bound for 5. So if the element is present, it returns iterator to that element. It works same as find function if the element is present. So it will return iterator to 5. And we are using dereferencing operator, so we'll get the value 5. So this iterator is not s.end, right? So we'll go inside the if case and we'll print 5. So this program will print output as 5. Output of this one is 5. Now let us change this program. Let us say we want to search something like 6, which is not present. If something is not present, then it returns the iterator to the element which is just greater than this. So just greater than 5 is, just greater than 6 is 10. Right. Please note that there is one more greater element. We want the smallest greater element. Right. That is the purpose of using lower bound function. So we get iterator to 10, and this program will now print 10. Because this is not pointing to end, so it will go inside the if condition and it will print 10. Let's change this program further. Let's say we want to find lower bound for 25. An element which is greater than the greatest. The greatest one is 20 and 25 is greater than the greatest. Now if you call lower bound for 25, it will return s.end, because there is no greater element than 25. And where does s.end point? It points beyond the last element. It's never a good idea to dereference s.end, right? Because it's some invalid location beyond the last. So that is why we had this if else, right? So in this case, it will print this given element greater than the largest. This line will be printed as output. Given element greater than the largest. Let us now talk about upper bound function. Upper bound function on set works similar to the upper bound function for arrays or vectors. The difference here is it's a member function, so it's better to use upper bound when you have a set, upper bound member when you have a set. So how does this work? If you pass an element which is present, then it returns iterator to the next greater element just next to it. If you pass an element which is not present, then it returns iterator to the element which is just greater than it. If an element is greater than the greatest, then it returns s.end. So the last two things are similar to lower bound. If an element is not present, then it returns iterator to the next greater. If the element is greater than the greatest, then it returns end. Only the first case is different. If the element is present in the lower bound, it was returning iterator to that element. Now it returns iterator to the next element. So let's say we have 5, 10, 20. So we call upper bound for 5. What it will do? It will print 10, right? Because 10 is greater element than 5. Now if we change this, if we change this to say 6, then what will happen? Then it will print 10 again, right? Because the next greater element, then 6 is 10, the lowest greater element. Now if I pass an element which is not present and greater than the greatest, something like 25, then it will return s dot end, and the output will be given element is greater than the largest. This is what we get when we pass an element which is greater than the largest in both lower bound and upper bound. Let us now talk about internal working and time complexities of different operations for a set. Set is built on top of self-balancing binary search tree, and in particular red-black tree. So internally set uses red-black tree. A red-black tree is a self-balancing binary search tree where you have height of it as log n. So if you want to insert an item in a self-balancing BST like red-black tree, if you want to remove an item or you want to search an item, all these take big O of h time, and h is ensured to be log n. So the time complexity of search, insert, delete in a red-black tree is big O of log n. That's the internal representation of set. And you remember, right, if you traverse a binary search tree in order fashion, you get the items in sorted order. So that is why when we iterate through a set, we get the elements in a sorted order. Let us now talk about time complexities of different operations. So these operations, begin, end, R begin, R end, C begin, C end, so and CR begin, CR end, they all are big O of 1 because they simply return iterators. These 6 operations, they return iterators, CR end, right? They return iterators to first elements and last elements, and with these iterators might be stored internally, so they just return in big O of 1 time. Size is also stored with the container, so it's big O of 1. Empty is also big O of 1 because it just has to check whether size is 0 or not. Let us talk about these functions: insert, find, and count. So insert function, since it is a red-black tree, it's going to be log n. Find function, again log n, because it's a red-black tree, you will have to search across the height. Count function is similar to find function. Find function returns an iterator, count function returns 1, 0. Lower bound, upper bound, they are also search functions. They also traverse across the height. So both of them are log n. Erasing a value. For erasing a value, you need to search it. So it's big O of log n. One extra note about erase: if you pass a value which is not present in the set, then it simply ignores it, right? If you pass a value, then it finds that value and erases it. So all these operations are log n. Here is an interesting fact: if you pass an iterator to the erase function, which means if you have address of a node in red-black tree, then amortized time complexity is big O of 1. So if you are doing, say, X delete operations, in all these delete operations, you have address of element to be deleted, then on average, all these operations take big O of 1 time. Let us now talk about an example program where we use set for a user-defined data type. So we have a user-defined data type. I have created a simple user-defined data type so that this program fits in this board. So this data type has only one member X, and we create a set of this test type where we insert multiple test objects. So I insert an object. So in case of structures, we can create an object this way. So I create an object with value x5, then 20, then 10. So this set contains now 3 objects of type test. Now when we traverse through the set, we see that these object x values are printed in increasing order. The output is 5, 10 and 20. Why? Because we have overloaded this operator. So if you want to use set for your own custom data type, you need to overload this operator and you need to specify the order in which you want to place the elements in the set. If you want to place them in increasing order, then you put this. If you want to put them in decreasing order, then you replace this with greater sign. So that's how you create a set for a user defined data type. Applications of set. Set can be used anywhere, wherever you want to use a cell balancing binary search tree, because it's an implementation of cell balancing binary search tree. Now the applications of cell balancing binary search tree or set are the places where you want to maintain sorted order of stream. So you have a data coming in which is unsorted, like 5, 10, 2, 25, 12. This is unsorted data, but you want to maintain it in a sorted way. If you use an array, then it will be really costly to maintain the data in a sorted way, because every insertion will cause big O of n time complexity. But if you use set, every insertion is going to be log n. So if you have unsorted data and if you want to maintain it in a sorted order, you use set. Let us now talk about next application. Next application is doubly ended priority queue. So with normal priority queue, you can either make a priority queue that implements max heap, or you can make a priority queue that implements min heap. But if you want to implement a priority queue where you want both maximum item and minimum item in big O of one time, you can use a set, because if you do s.begin, you will get the minimum item if your set contains elements in the increasing order. If you do s.end -1, you will get the maximum item, and both these are big O of one operation, and you can do other operations in log n time. So whenever you need a doubly ended priority queue, you use set data structure.